So I think we're going here. Um, you all bear with me as I try to explain this on here as best I can. So, first thing I want to do is to have you get out your duct slide. So, this duct slide is pretty intimidating at first, and honestly, it can be pretty complicated or it can be pretty simple. There's parts of this that you'll probably never use, and depending on if you're doing the same types of system over and over, you may only use a couple of different parts of this every time. So um, this is actually a lot more complex than the one that I grew up using. The one I still use a lot. It's a little rectangular looking slide, kind of slides in and out. So either one will work, but this one is good because it does have some equivalencies for duct board and flex duct, that kind of stuff. So without any further ado, I want to make sure that you can see this. Now I know my camera is a little fuzzy, so I apologize in advance. I'm going to try to explain what I'm talking about. So if you turn to this side of the duct slide, excuse me, I got something in my eye. This side of the duct slide, you're going to see at the top galvanized metal, volume in CFMs, wire helix flexible ducts, so that's what we would call flex, and volume, which is CFM, cubic feet per minute of that. So it does have a wire flex duct with a wire coil in it. So it does calculate for flex. Now at the bottom, you'll also see friction rate, duct liner, duct board, CFM. And I apologize if some of this stuff is backwards. I don't know if it'll flip it whenever I finish recording, but it looks backwards to me. So, but if you've got yours, you can kind of follow along with where I'm going. You'll also see in the middle that it has this little chart here and this little chart here, and then these two here and here. So the round duct diameter, that's going to give you, if you're running a round pipe, when we move this to wherever we're going to move it, it's going to say, okay, this is how big the pipe needs to be to move that much air. So the whole purpose of this thing is to just tell you, like, at your friction rate. So if you can calculate your friction rate, or as a lot of people do, they end up just using some generic 0.1. It's not the best way to do it, but it's just, you're probably going to see people do it. So I'm going to show you how I would do this at some generic friction rate, and I might use 0.1 just to show you how that works. And then if we can run this at the friction rate that we calculate in class for the longhouse, then we can compare the difference in the sizes of duct from 0.1 down to whatever you'd actually be using based on your calculations. So that'd be a good, interesting comparison to see if it changes the size of your duct a lot. All right, so the first thing we need to know is what friction rate we're going to use. And like I said, we're going to use 0.1. So I'm going to go to, I got to know what type of duct I'm using. Am I using duct board? Am I using duct board and flex? Am I using metal trunk? So the trunk is the main part, and the branches are the parts that are going to the individual rooms. So what type of system, what type of materials am I using? Am I going all metal? So I've got metal trunk and metal branches, or am I going metal with flex, or am I going metal all the way? So metal duct and metal pipe. That's just going to depend on your application, and that's probably going to make a difference in the cost of your bid. So if you're going all metal, then most of your generic, those little rectangular slide rules will work for that. One of the things, I don't have one of those with me, I don't think. No, I don't. But one of the things you'll notice on those little slide rules is they will say this is for metal duct only. And a lot of people will use that, and they'll use that metal duct, and then if you compare it to the flex or to the duct board, those numbers will be different, but most people don't know that or account for that. So that's one thing to keep in mind, and that's one reason I do like this, because it does give you a little bit of grace in that area, and it kind of calculates it for you. So we're going to say that we're going to use a 0.1 friction rate, and we are going to, I think we're going with metal on this. So we're just going to go straight metal, and then we can make some adjustments later if we want to. All right, so the first thing you're going to look for is your total CFM. So I think most of you all came up with about two, somewhere around 2 ton, maybe a little more, a little less. So for argument's sake, let's just say 2 ton. So what is your cubic feet per minute at 2 ton? It's 400 CFM per ton is kind of the standard, once again, rule of thumb, but it's kind of what we're going to go by. So 400 cubic feet per minute and per ton. So we have 2 tons, 800 CFM. So that's going to be our starting point. So once we know our friction rate and we know our CFM, design CFM, so it's going to be based on our system size. That's going to come from manual J. It's going to come from your room by room load, and it's going to give you your total BTUs and your total needed CFM. So I think once you run those speed sheets, or you ran it through RightSoft or some other program, CoolCalc or whatever, we came up with about 1,100 and some odd, between 1,100 and 1,300 CFM, I think, needed for the house. Then you're going to go room by room and say, okay, I know what I need total. Now, what does this room need? And so those 3 programs, the speed sheets, the RightSoft, and the CoolCalc, will all give you room by room loads. And so you're going to use those then to size your individual ducts. So once you have your friction rate, which was kind of assigned to you to try to come up with. So that may be something we will go over later. But for now, I'm just going to show you a generic overview, and then we'll get more in depth with specifics on the friction rate as we go. So using 0.1, up here at the top, I'm going to go to galvanized metal duct. And they make a digital version of this, but I can't get it to download to my computer. It would be so much better if I could use that, but here we are. So I'm holding up this little card, and you're not going to be able to read it, but oh well. So follow along with me, and I'm going to read the numbers out, and you can kind of see where I'm pointing, but you're probably not going to be able to read that. So galvanized metal duct, friction rate of 0.1, and that is per 100 feet of duct. So at the very top, I'm going to find the 0.1. And I'm going to line that up in this white column with 800 CFM. So I'm going to turn this until that 0.1 hits 800 right here. And if you can't read that, trust me, it is. So 0.1 is on the top, setting at 800 CFM. All right, now leave that there, and you're going to look down at the inside. So don't worry about all this other stuff at this point. So at this point, we know we're just using metal. So this inside is going to tell us the size of the pipe or the size of the rectangular duct. So let's see here. I got to look. Okay, so first of all, round duct diameter. So 800 cubic feet per minute can move at a 0.1 friction rate through what appears to be a little over 12 CF or 12-inch duct, give or take. It looks like it's a little over. Now, what do you do in that case? You can't get 13-inch duct. If it's really, really close to 12, I would probably maybe round down, but normally in duct, I usually round up. It's just me, and from everything I've seen, because most systems, especially if you design them at 0.1, if you don't know your exact friction rate, are going to be undersized. And so I always err on the side of oversizing if I don't know the exact friction rate. And so I'm going to go ahead and maybe round that up to 14. Now, what does that mean? That means that at 800 cubic feet per minute, if I wanted to move it through a round pipe, a round metal pipe, I could move it through that pipe and maintain that friction rate and not put too much static pressure back on my motor, not work my motor harder than it needs to work, because we calculated that all, hopefully. But I can move that much air through that 14-inch duct. All right, so that's if it's round. Now, what if it's rectangular? So if it's rectangular, you're going to go down to the next part. So the rectangular part, over on the sides, it says rectangular size for round duct friction rate, and then rectangular size for round duct friction rate. On these, I think it's just basically broke down in increments. So on this side over here, if you'll notice inside of here, these numbers are really small, and the numbers on the outside are pretty large. And then this one seems to be the other way around. So this is 3 to 20 in the gray, and then you've got these other numbers here. This one is 20 to 90, and these down here are really small. So I'm either any of these will work. Normally, it seems like in residential duct, at least from what I've worked with, most of your widths tend to be 8, 10, maybe 12. Uh, in a if you got a lot of room, but you got to think this duct work is, it's sticking down this far, and if it's duct board, then it's got an inch of insulation on top of that. So you're measuring the opening, you're not measuring the outside, you're measuring the opening of the duct. So how much can air actually go through it? If there's insulation on the outside of that, or if there's duct board, that doesn't count in the diameter, but it does take up space. And so you have to be aware of your headspace. How much room do you have above? Do you need, is clearance an issue? Is it going to be under a house, above an attic? If it's in an attic, it probably really doesn't matter too much. So you might be able to go taller. And if you go taller, then you might not have to go as wide. So how do we read this? So we've got our thing set at 0.1 at 800, and that's between a 12 and a 14-inch duct, round duct. All right, now go down to this other column, and I'm going to find 8-inch on one of these charts. It really doesn't matter which one. I'm going to try to find 8-inch right here. So I'm going to use this first one as my width. All right, 8. And then if I line that up, mine looks like it's close to 18 right here. So I'm going 8-inch wide by what? 8 by 18. So what that's saying is this 12 to 14-inch pipe is equivalent to 8 by 18-inch rectangular duct. All right, so that's going to be, that rectangular equivalent that I'm going to use if I'm using rectangular. All right, so how does that factor in? At this point, I'm going to have to probably show you my screen, which means you may not be able to see me quite as well. I'm probably going to be down in the corner, little thing. So hopefully you've got this. I'm going to kind of point. I may have to come back to this on occasion, but if you can try to follow along as best you can, I'm going to pull up the blueprint for the house and the duct design right now and let you see. I'm going to try to build this duct system the way that I was trained to do it, the way I would do it. All right. So at this point, hopefully you can see this screen. So on this screen, what I've done is I just put it in a Word document so I can edit it and I can draw on it. You could do it in WriteSoft as well, but I just went into the WriteSoft and I took the floor plan and the duct notation. Actually, I didn't put the duct sizing. I just put the duct layout. So I may have to reference back to that, but I'll just reference back to that page. Let's see here, duct notation. Let me see if I can pull this over without it getting too messy. It gets a little messy when you add all those numbers. Let's see if I can do this. So that we know what each room needs. All right, so I just went in there and I just copied that, and I'm just going to delete this now. Oh gosh, I do that. All right, so I made this little box. This is going to be my little ductwork box, my piece of duct. So I'm going to paste this new page. I'm going to try to blow this up as big as I can because I don't have a lot of room. So we got some room to work. I may even Even change the margins to narrow, so I got plenty of room to spread this out. All right, there we go. So now I made this little box, and I've tried to make it as close to, and normally I would just do this on graph paper or something if it was me, or this is the way I was kind of taught to do it. So I'm going to make this as close to 4 feet. I think I got it at 5 as I can. All right, so most of the time your duct is going to come in 4 feet lengths. So each piece of duct is going to take up 4 feet. Now, you could do this different ways, but the ideal way is that your air handler would be as close to the center of the house as you can. That way you're dividing up the most of that air both directions as possible. If not, if you go from one end or the other, which happens a lot, my house is actually done that way, that it kind of goes from one end all the way to the other. Your duct will be a lot bigger because it has to carry everything. So by making it in the middle, most of your duct can be smaller because it only has to carry half. So what does that look like? Well, I'm going to just come down here and I'm going to try to split this. So your first piece of ductwork is 4 feet long. We don't know how wide it is yet. So what we're going to do is, and I'm going to try to copy this, and then I can just reuse it and make another one. And I can just keep moving that down and I'll make my ductwork. All right, so I'm going to go to my ductulator. I'm going to stay at 0.1, and I'm going to say the first piece of duct needs to be what size? Well, we already sized that. So the first piece of duct has to go in the middle of the air handler. So this is your first piece. And that piece of duct has to handle everything the air handler blows, which is 800 cubic feet per minute in this case. So in this case, at 800 CFM, now granted, our numbers are going to be way off on this because I have an issue with my heat load. So yeah, so probably don't pay attention to these too much, these numbers. I've got to figure out what's going on with my load. It's got me losing a lot or gaining a lot more heat through my ducts than necessary, and I can't figure out how to change that in the design. But this is just kind of showing you the process, so kind of look over me if you can. All right, so down through here, this is showing me my supplies, but it doesn't show me the sizes. And so I'm going to kind of draw the sizes in the way I would do it. All right, so here's your first piece. It needs to be 8 by, what do we say, 18? Yeah, 8 by 18. All right, so let's see if I can insert text. 8 by 18. All right, or it could be, let's see, if I keep that in the same exact spot, if I move over on the bottom to the, from the 8 to the 10, I could also make it about 10 by 12. So if you see that, you see what I'm talking about? My 8, if I move over to the 10, I could make it 10 by 12. So if I wanted to make it narrower, but a little taller, I could make that first piece a little taller. And so I could make that 8 by 10, or if I wanted to go down, see if it'll let me do that. Or I don't know if I have room, or 10 by 12. All right, so I'm just going to keep it at 8 by 18. That's not huge. All right, so the next piece. Oh, so first of all, are there any vents that come out of the first piece? There really shouldn't be. That's not saying there won't be at times, but there really shouldn't be. You want that first piece to kind of just be able to carry everything. All right, so then the next piece, I'm going to go to the left. I'm going to go to the north. So going north, the next 4-foot piece has to be big enough to carry everything on that side. All right, so in this case, so now granted, we only have 800 available, and this is going to be way over that. So I'm going to have to kind of change some of these numbers a little bit. So let's just go with this 129 up here. All right, so this first piece is 129. So I'm just going to say that it's, yeah, let's just say it's 129. All right, so go to your 0.1. Now here's where you have to kind of work each individual duct. So what size does that run need to be if it was 129? If you go to your point 1 and you slide it all the way down until it gets to about 129.1, it looks like, let's see. Okay, it looks like when you go to your round equivalent back in the middle, your round duct size, it looks to me like we're between a 6 and a 7-inch duct. Now, here's some rules of thumb that I grew up with. So, a 6-inch duct, a 6-inch flex will carry 100. A 7-inch flex will carry 150. An 8-inch flex will carry 200. That's kind of your main duct sizes. A 5-inch flex will carry about 50. Now, those numbers aren't exact, and you can kind of dig into this and see how they're a little bit off, but it'll actually get you pretty close. So just in a ballpark. So I could look at that 129 and say, yeah, it's going to be probably a little more than a 6, or right about a 6. All right, so right now I'm not worried about sizing those runs, but I need to know how much came out of it. So I really didn't need to know that it was a 6-inch right now. I'm just kind of showing you how that works. So I'm just worried about the trunk right now. So this first piece of trunk has to be big enough to carry everything on this end. All right, so we only have 800 available. So like I said, obviously my load is a little off. But we're going to have one in each room and probably a couple here in the living room. So I'm going to change these for simplicity's sake. And I'm going to say that all of these, all of these on the left side are all, let's just say in this case, they're all 100 apiece. So don't worry about the CFMs that's marked on there. So 100, 2, 3, 4, 5, 6, and then on this end, 7, 8, 9, 10. This one's half, that's 50. And this one, we could say that one's half. So 11. So we're still a little over. I'm trying to figure out if I've. Oh, in this bathroom. Okay, I'd say this bathroom's a little less than that. So I wish I hadn't put those duct notations on there. I'm sorry about that. So in this first one, let's just say that this first piece is in a bathroom. Doesn't take a lot in a bathroom, although this is a pretty large bathroom. And it's going to be 50 CFM. All right, so scratch the 129. All right, so how much did we have going to the left? Well, 50, 100, 100, 100. So we got 1, 2, 3, 4, 5, 50. 550. I know I'm confusing you all. I'm sorry. All right, so 550. I'm going to punch that into my duculator. I'm going to go to the 0.1. And I'm going to go to 550. And what that's going to tell me is this is how big that first piece of duct after the main piece has to be to carry that whole end. All right, so 550 appears to have a round duct diameter of about 11, but I'm not doing round, so I'm going to go to the rectangular equivalent. And it looks like it's about 8 by 13, so I'm going to round that up to 8 by 14. So this first piece, I'm going to make it 8 by 14. All right, so I can shrink this down if I want to make it look a little smaller, make it a little more accurate. All right, next piece. All right, so if nothing comes out of any of these individual pieces, then the duct size doesn't change. But in this case, it looks like most pieces have something out of them until we get to the very end. Speaking of the very end, you don't have to run your duct all the way to the end if you can reach it with your flex. So this one runs it all the way to the end of the house. You don't have to do that. As long as you can reach it within a small distance, you can stop short of the house. So we may actually do that on this. All right, so the next piece. So after that first 8 by 14, the 8 by 14 had to carry everything on this end. But in this bathroom, we said we took out 50 CFM. I know it says 129, but we said it was 50. So we took out 50 CFM. So how much do we have left? All right, so we had 550 going to the left. We took off 50. We have 500 left. All right, so now go to your ductulator. 0.1 at 500. Hopefully you're catching the hang of this. 0.1 at 500 looks like an 8 by 12. So after you take anything out of it, this is the way I do it. Now, there's different ways to do it. There's different ways to design it. If you look in Manual D, there's a couple of different methods that are different than this. This is the way I was taught. After you take anything out, you reduce it. All right, so your next piece is going to be big enough to carry everything that's left. Well, what's left? 500. So it's going to be a little bit smaller. And it looks like it's 8 by 12. So I'm going to write in 8 by 12, according to our chart. All right, there's that. Now, copy and paste me another picture, another square. I'll move that 4-foot square in here. And I'm going to say, okay, does anything come out of this piece? Now, this one's close, but let's say it doesn't. And so if nothing comes out of it, then what does it do? It stays the same. So it's 8 by 12. Okay. Next piece. Yeah. Okay, I'm going to stick this right here. Ooh, I got 2 coming out of this one. All right. We said they were all 100 apiece. All right. So did anything come out of the last one? No, wait. Okay. I messed up on that last one. So this 8 by 12 did have something come out of it. I didn't see it. It was on the bottom side. So it did have 1 come out of it. So this next piece should have been smaller. So we had 1, 2, 3, 4 left. So 400 at 0.1. And that looks like it's an 8 by 10. So this should be a 10. So you don't reduce until after the run comes off. You don't reduce in the duct that it comes off. You reduce after you've taken it out. All right, so that piece, nothing came out of it. So this piece remains an 8 by 10. Okay. Now, 2 came out of that, and we have 2 left. So as small as you're going to go is 8 by 8, and that's going to be just a little square piece. So in a lot of times 8 by 10 is as small as you'll go. But in this case, since it is a pretty small system, we have 100 and 100, we said, that came out of this one. So if I take 200 off of 400, I have 200 left. And I have 200 here, right? So 1 and 1 here. So I have 200 left. So I'm going to put a 0.1 on 200. And I should come up with, it shows me 8 by 6. I'm not going to go smaller than 8 by 8. So the next piece will be 8 by 8. And some people would probably leave that 8 by 10. But you can do either or. 8 by 8. At this point, we're really getting toward the end. So like I mentioned before, I would put another piece of 8 by 8. And I might not if I could reach it from there. So let's put one more. So this one's still going to be 8 by 8 because nothing came out of that piece. And then at this point, I should be able to stretch these to that unless there's something prohibiting me from doing that. So if you have to go all the way to the end, you can, but you're not going to want to. It just increases the cost of your, yeah, this is my Hallmark watching cup, if you're seeing my camera here. So it's my wife's cup that I'm borrowing. So cute. All right, so 8 by 8 on this last one. All right, there's that. So now this next piece, this next side should be pretty easy. So it's the same thing over. We just got to go the other direction. So we got to say, okay, how much is left? Well, we had $800 to start with. We took off 550. I think our math's not going to come out right. I think we need to make our first piece bigger. I think when we did our stuff, it did come up to about 1100. So it's possible that you might need a little more than 400 CFM per ton. If your house is built really well, you might have to upsize your blower or speed your blower up to move enough air, because the house is built well. There's not a lot of heat load, but you still have to be able to move the air. So this first piece, we may have to upsize that. So if we say all of these except for the bathroom and the hallway are 100, and these are 50 apiece, or the entrance, I mean. So you got 50, 50, so it's 100, 2, 3, 4, 5. All right, so let's say 5 on that end. And so it looks like that puts us at 1050. All right, so if you go to, let's just round it off. Yeah, okay. So if you got 500 on that end, the first piece should have been big enough to carry 1050. I know I'm jumping around all over the place, guys. It's really hard to do this like this. All right, so the first piece, 0.1 at 1050, should be increased to about, it looks like, if I go over, I might have to go over to the right-hand chart. It looks like an 8 by 21, 8 by 22. So I'm going to put that at that. Or I could do 10 by 18. So let's just do 10 by 18. Okay. And it's not going to let me put that in there. There we go. All right, so now next piece has to be big enough to carry the 500 that's going that way. So we said there was 5. How big does it have to be at 0.1? So 0.1, we go to 500. We'll give you just a second to get there. So 0.1 on your friction rate at 500 CFM should be about a 10.5 inch round duct, which would correspond with an 8 by 12 rectangular duct. Okay, did anything come out of that one? Yes, this one down here by the door did. So the door, we said that was 50. We were going to change that number. So the door took out 50. So now we have how much left? We take off 50 of 500, we should have 450 left. So 450 left is about a 10-inch round, or an 8 by 11. So it's still, I'm probably still going to keep that 8 by 12. So paste that. Normally I do this on pencil, with this pencil and paper. It's just easier, but this is a good way to show it on here. 8 by 12, because that 50 really didn't change much. So need another piece. I'll bring it down. All right, so I'm going to bring 100 out of this one. Now it still needs to be 8 by 12 because it has to be big enough. Then after I take it off, the next piece is going to be smaller. So paste. Next piece, 450 minus 100 gives us 350. 0.1 at 350 should be about 8 by 9. So I'm going to round that up to 8 by 10. All right. And then another piece. Now notice these others, these dotted lines, those are returns. So don't pay attention to those. All right. So nothing comes out of this piece. So still rocking 8 by 10. Keep going. Next piece. You really got to get the scale of like where 4 feet comes to get an idea of how much you're going to need. Because this is what you're going to use to make your parts list. So you have to know how many pieces of 8 by 10 you're using. So the next piece is still going to be 8 by 10 because nothing came out of that one. Now something's coming out of this one. So it's going to step down. The next piece is going to step down. So I had 100 come out of that one. So now you're going to 350 minus 100, so 250 at 0.1. Put you at 8 by 7, so we're going to go 8 by 8. Never go smaller than 8 by 8. And that's probably going to be my last piece, because I can get the rest of those from there. All right, now, if you move these around, so let's say this one over here in this bedroom, if I moved it to this other window, it would actually come out of another piece. So you kind of have to know where you're going to put them when you're laying out this house. If you're going into the house, you're looking, where's everything going to be? Kitchens, obviously, you have cabinets and refrigerators and stoves and stuff. So you can't just put it anywhere. You can't put it in the middle of the room or whatever. You might not be able to put it where you want it. You have to get creative. So just be aware of that. Usually supplies are going to go under the windows, not always, and usually on exterior walls. Returns are going to go more than likely on the interior walls or in the hallway. So if possible, I like to have returns in all the rooms that are all the rooms that are going to be closed up. So like bedrooms, living rooms, no bathrooms, no kitchens, no dining rooms, and maybe a dining room. No laundry room, no entrance because you're going to pull air from outside as the door opens. So mainly bedrooms and living, maybe a hallway. A lot of times you'll see a central return that's just in the middle of the hallway and it pulls from the whole house. But room by room is better, really, because that way you're pulling air out of each room, you're circulating air back in. But you'll see them both ways. All right, so you're just going to basically do it the same way. It's going to be pretty quick. So first piece still has to be big enough to carry everything. Some people, I think there's some ways that this one actually needs to be maybe a little bit bigger, if anything. But basically the same outfit. It has to be able to handle everything. So 10 by 18. All right, and then I'm going to just start going both directions. And let me change the color of this. Copy that so I can use it again. All right, so these other dotted lines, this is my return duct. So if I have 800 CFM of supply, I have to pull out 800 CFM of return. So this first bedroom, I like to pull out about the same amount out of each room. So if I put 100 into this bedroom, I want to pull about 100 out of it. So first piece of duct, it looks like it's going to be right on the edge, but let's say it catches it. So the first piece of duct has to handle 1 bedroom, 2 bedrooms, 3 bedrooms. That's your 3. So you got 3 there. So if they're 100 apiece, ignore these CFMs. If they're 100 apiece, and that's 300 on that end. And then on this end, you're going to have a big one in the living room because it's bigger space, and possibly one in the dining room or the hall. So in this case, let's just say we're going to just do the bedrooms on this. So 1, 2, 3. So how big does a piece of duct have to be to handle 300 CFM at a 0.1 static? Looks like it needs to be about 8 by 8. I'm probably going to go 8 by 10 just because it seems like if I'm going to run it that far, it seems like a long way to run 8 by 8, just in my opinion. And now at this point, you may not run a lot of return duct work. If you're just running 8-inch runs, you could probably flex that back to the air handler, and you may not have to put much duct at all on these. Now, if you have a big main one, sometimes you'll have to, but all right, so we took one out of that one. So let's say the next piece, it could be 8 by 8 or 8 by 10. It's either one would carry it. Like I said, it's not gonna be very big. Since it's so small, I'm gonna keep this 8 by 10, and maybe this last piece, I'll make it 8 by 8. When you get down past 8 by 10, you're getting into pretty small space. All right, and that's going to cover those last two. Same thing with the other direction. So now we had 3 out of that side, so it means we got 5 on this side to take care of. So let's say, even though this looks like a bad spot to put it, let's say in this hallway, right in here somewhere, we're going to put a main return. So we've got a bathroom that doesn't need a return, a kitchen that doesn't need a return, a laundry doesn't need a return, the dining room, could, may or may not. The living room's going to have a pretty large return. So let's just say that this living room is going to be our big one. So we've got 1 in the dining room. So let's say the dining room has 100. And then let's say the living room one has to be able to carry the rest of it. So we had 300 off the right side, 100 in the dining room. So that's 4. So we got 400 left. Sorry, I forgot we went back to 1100. I'm sorry. So 10 by 18, it's not 800. We're working with 1100. It's 1211 at my house right now. I'm a little bit tired, so excuse me if I get my numbers mixed up. 1211 in the night. So nothing changes on this end. This end, it will change a little bit. So we had a 10 by 18 piece. This big one needs to be bigger. So we've got 1 in the dining room, and that's it. So the rest has to come out of this big central return. So how big does this whole end need to be? We had 1100 minus 3, so we have 800 left. So go to 800 at 0.1. 8 by 18. All right, next piece. All right, so let's say out of that piece, we bring this big return. All right, so it's a big one. All that's left on the end is an 8 by 8. So that 8 by 18 is going to be, it has to be big enough to carry 400. Let's see, sorry, 700 CFM. So 700 at 0.1, just to give you an idea, is 8 by 16 on its own. So we're not going to be left with much because all we have left is 100. So take 0.1 all the way down to 100. It gives you a 6-inch round diameter and less than 8 by 8. So we're just going to run 8 by 8, a few pieces. Like I said, you'd probably flex this over before too long, and you would have to run duct all the way to it, unless you was just trying to keep it up in the joist to keep it neat. So the last couple pieces are going to be 8 by 8. Okay, so there's a basic layout, and then from that you can make a parts list. So you could come up with how much duct you need. I need so many pieces of 8 by 8. There's not going to be a difference between return and supply duct. It's just how you put it. So I'm going to need 1, 2, 3, 4, 5, 6 pieces of 8 by 8. I'm going to need 1, 2, 3, 4, 5, 6, 7 pieces of 8 by 10. So when you're making your parts list, that's what you'd order. So that's how you do your trunk. And I'm just going to save this, and I can send that in, and then you'll come up with your sizing for your flex. We'll do that later. Your sizing for your flex, and then that's going to give you your parts list on that. So thank you for bearing with me. I know this wasn't the most clear and concise, but hopefully it will at least get you started in the right direction. And then when we break this down, I got to figure out what's going on with my load to get these numbers right. But once I get that corrected, we should be good to go. So that does give you a layout, at least, of how you would kind of work through it at a 0.1 static. So once you know your static, your friction rate, it's not that bad, but you got to be able to calculate the friction rate. So you all are learning how to do that. Once you learn your actual friction rate, then you can punch that in if it's 0.5 or 0.6 or whatever. It seems like a lot of times that friction rate actually tends to be less. And so just for an example, let's say that we're moving 1100 CFM at 0.1 like we were. So go back up to that and just remember what that was. So 1100 CFM at 0.1 looks like it is 8 by 22 or so, or 10 by 18. If I take that same amount of air and I reduce it to a 0.06, which is not that uncommon, or even a 0.05. So at 0.05, 1100 CFM takes an 8 by 30, about a 32, or a 10 by 25. And you may think, well, why would you want to go that way? Why would you want it to be bigger? Well, if my static actually comes up to be 0.06 or 0.05, and I put it at a 0.1, I'm massively undersizing this ductwork, which means I'm putting a lot of back pressure and a lot of extra load on this motor. And my motor is going to, probably burn out earlier than it should. My system's not going to move enough air. The house isn't going to be comfortable as it should be because I'm assuming that I can move it through that, but I can't because I have too much length of duct, or I have, an aggressive filter, or whatever, some stuff in there that's, prohibiting airflow. So you have to account for that if you really want to get an accurate measurement of how much air you're going to move and how big the duct needs to be to do it. And so that gives you an idea of a comparison. So we're going to stop this right here, and we'll pick up from here later. Thanks.